Hey everyone, and welcome to The Explainer. If you're looking to seriously upgrade your AI architectures today, you are exactly in the right place. We're exploring a truly fascinating topic, multi-agent RAG orchestration patterns. To really wrap our heads around what we're doing today, I want you to think about it through an organizational metaphor. We are basically taking a brilliant but completely overwhelmed AI solo worker, and we're transforming them into a highly efficient, specialized corporate team. Now, it turns out multi-agent systems actually date all the way back to the 1990s with frameworks like Jade, but it's the modern LLM era that has suddenly made orchestrating these specialized AI retrieval agents incredibly practical and, honestly, incredibly powerful.
Okay, let's dive into this. Here is our roadmap for the explainer. We're going to cover the single-agent bottleneck, enter multi-agent orchestration, look at the three core topologies, explore the Crew AI alternative, figure out how to choose the right setup, and finish up with some pitfalls and pro tips.
Section 1. The single-agent bottleneck. The jack of all trades.
Picture an overworked employee sitting at a desk that is just piled high with totally different tasks spanning completely different domains. And worse, they're expected to be a flawless expert at every single one of them. Well, that is your generalist AI right now. It brings up a really important question. What actually happens when you give one AI a dozen different tools? I mean, it sounds incredibly powerful at first, right? But the reality hits hard. If it has to search a vector store, query a SQL database, validate citations against source documents, and then format a research report all in a single turn, the system just begins to break down. You get severe tool selection noise because the model gets confused about which tool to use as the options increase. You get prompt bloat because you're trying to cram every single domain into one massive system prompt. And eventually, the agent just completely loses its focus. And this brilliantly illustrates the fix: specialization. Looking at a monolithic architecture versus a modular one, the contrast is literally night and day. A single agent is a monolithic single point of failure. It's totally opaque. If it fails, good luck debugging which capability actually broke. But a multi-agent system? It is perfectly modular. You have domain-specific prompts and, absolutely crucially, scoped failures. LangChain's research actually confirms this approach. They found that splitting work and grouping tools across specialized agents drastically improves both the accuracy and your ability to debug the system. It's like, if one specialized agent drops the ball, the rest of the team can still keep playing.
Section 2. Enter multi-agent orchestration, building the team.
So, we are essentially moving from a single messy desk to building a crystal clear organizational chart for our AI. In this team structure, each agent acts as an independent entity. It gets its own specific prompt, its own LLM, and its own dedicated toolset. But when exactly do you need to make this jump to a team? 5 or more tools is the exact threshold where developers really need to ditch the basic single agent and start actively considering multi-agent orchestration. When you hit this number, you likely need different prompts for different tasks, or you need parallel execution where multiple searches are just running simultaneously. It's also the point where team-based development makes a ton of sense. Different engineers can actually own and optimize different agents on the team.
Section 3. The three core topologies. The org charts of AI.
Let's move to and see how this builds as we explore the three dominant land graph frameworks. These dictate exactly how our AI agents are connected, how they communicate, and how control flows between them. First up is the supervisor pattern. By definition, this is a setup where a central coordinator agent routes tasks to specialized workers, collects their outputs, and decides the next step. Think of this as the classic manager of your org chart. The supervisor itself is an LLM, and it's reasoning about which agent to call next. Importantly, though, the worker agents have their own independent scratchpads. This means the supervisor doesn't get totally overwhelmed reading every single intermediate tool call. It only sees the final summaries from the workers, which totally prevents information overload. Let's look at a concrete multi-source retrieval augmented generation or RAG example of the supervisor in action. Step 1. The supervisor router analyzes the user query and routes it to the analysis agent to query an active user database. Step 2. Once it has that data, it routes over to the retrieval agent to search documents for expected growth metrics. Step 3. It routes to synthesize and finish. The router explicitly dictates the sequential workflow. It ensures absolute quality control before ever delivering the final answer to the user. Our second topology is the swarm pattern. This is defined by peer-to-peer handoffs via function returns with absolutely no central coordinator.
If the supervisor is your traditional corporate manager, the swarm is a flat hierarchy, dynamic tech startup where all the agents are equal peers. It has its roots heavily popularized by the OpenAI Agents SDK, where an agent can just hand off execution to any other agent by simply returning a reference to it.
Because of this highly decentralized nature, the swarm pattern is absolutely perfect for customer service triage and dynamic routing. The control just flows naturally based on the conversation. It's completely stateless between calls and highly lightweight. So a triage agent can look at an incoming query and instantly decide on the fly, oh hey, this is a simple question, I'm handing this over to the chat agent. Or, wait a second, this needs complex data, passing this to the analysis agent.
The third core topology is the hierarchical pattern. This is a tree of supervisors, where top-level supervisors delegate to team leads, who in turn manage their own subteams of workers. This is your massive, multinational corporation structure. It maps perfectly to LangGraph subgraphs and is designed specifically for large-scale enterprise RAG systems that require 10 or more agents spanning multiple complex domains.
Think about how that domain separation works at such a massive scale. A top-level supervisor routes a user query directly to the research team. That team is its own compiled graph with internal nested tool calling loops. Maybe they're searching vectors, checking the web, verifying citations, and it aggregates its findings. Then, the top supervisor routes those findings to the analysis team, which crunches numbers in a database. Finally, it routes to a synthesis node. It basically allows distinct enterprise teams like legal, engineering, and finance to own and operate their own distinct knowledge bases.
Section 4. The Crew AI Alternative. Project Management.
Now, what's really interesting about this is the contrast in abstraction. We've talked a lot about LangGraph, but Crew AI is a distinct framework that trades all that low-level graph wiring for a much higher-level project management approach. LangGraph uses low-level explicit graph wiring, managing nodes, state, explicit typed dicts, and reducers. It gives you ultimate control. Crew AI, on the flip side, uses high-level role, goal, and task declarations. Instead of wiring up graphs, you just define agents with roles and tasks with expected outputs. Crew AI focuses heavily on automatic internal memory and delegation right out of the box, meaning you don't have to manually code the state channels yourself.
Section 5. Choosing the right topology. The decision matrix. All right, this is the real climax of our explainer. We're going to help you actually hire the right organizational structure for your specific project so you aren't wasting time and compute. I want you to focus specifically on the best 4 column here to grasp the core utility of each. Supervisor is best for structured multi-source RAG with low explicit graph abstraction. Swarm is your absolute go-to for dynamic customer service triage using low-level function handoffs. Hierarchical is for large enterprise domain separation via nested subgraphs. And Crew AI, that's the champion for rapid prototyping and role-based setups with high abstraction.
Let's give you some rapid-fire definitive rules for your developer toolkit. Use Supervisor when you have 3 to 5 specialized agents with really clear specializations. Go with Swarm for unpredictable dynamic routing where you want minimal orchestration overhead. Choose Hierarchical when you're managing 8 or more agents and really need the scalability of nested delegation. And use Crew AI when you naturally think in roles and need built-in memory without wanting to wire up any graphs.
Section 6. Pitfalls and Pro Tips. Avoiding org chaos.
Look, as powerful as multi-agent orchestration is, these systems aren't magic, and they can absolutely crash your application if you aren't prepared for the dysfunctions. So the crucial point is knowing exactly how to fix these pitfalls. If your supervisor gets stuck in an infinite loop, and hey, we've all felt the pain of those massive API bills, add a max routing iteration limit. Simple. To prevent handoff ping-pong in swarms, where agents basically just toss a task back and forth forever without doing any real work, set strict maximum handoff rules. To avoid context window state explosions, explicitly summarize your subteam outputs before passing them back up to the parent supervisor. And to stop runaway routing costs, use cheaper models like GPT-4o Mini solely for making those routing decisions. You can even wrap agent nodes in try-except blocks so one failure doesn't crash the whole shebang.
But if there is one cardinal rule of AI engineering to really ground you today, it is this. Start small. Seriously, most problems only need 2 to 3 specialized agents, not a dozen. Do not over-engineer simple tasks. You should only add more agents when a single agent demonstrably struggles with tool selection or complex prompts.
I will leave you with this final provocative thought. Bad routing means the right agent never gets called. So ask yourself, is your central triage prompt actually robust enough to manage the team? Remember, the routing decision is your ultimate bottleneck. Refining your prompt engineering for your managers is what truly separates a chaotic AI mob from a high-performing corporate AI team. I hope this sparks some awesome ideas for your next build. Keep learning, keep refining, and we'll catch you in the next explainer.